So we found out that this process of finding the limit of this expression as n approaches infinity is the same thing as finding the integral, as seen here, of this function f of x with respect to x from a to b. So before we learn how to actually find the area under the curve, let's find out a bit about integration itself. What exactly is this integration that we're making reference to? Well, integration would be the reverse process of differentiation. So dy by dx, we could say, is equal to 2x. So what we're expected to do is to find out what expression or what equation is differentiated to give us this equation right here. So the equation that we would have differentiated to get this right here would be y is equal to x squared, because when you differentiate y, you get what? 2x. But we could have had y equal x squared plus 2, and we would have still get 2x. Or we could even have y equal x squared plus 3, and we'd still get 2x. So the fact is, by having y equal x squared plus any constant, where we call that constant c, we are saying that every time we integrate, we're going to be left up with an extra constant. And that constant is saying this is a constant that would have disappeared when we differentiated. So when we integrate, we are supposed to have a constant there to represent that. Sometimes that constant is 0, but other times that constant can be any number. So in mathematical notation, what we say is that the integral of 2x with respect to x would be equal to x squared plus c, where c is some real number. What we're going to be looking now at some, what we could say, laws of integration. So for example, the basic one that you would have seen a while ago is the integral of some polynomial x to the n with respect to x. So all we do, as we said before, is reverse of integration, where we would have x to the n plus 1, because we would have subtracted 1 if we were differentiating, and we're going to divide that by the new power, n plus 1. And we're going to do what? Add the constant of integration, some real number. So now, let's look at an example. So we have the integral of x squared with respect to x, right? What are we going to do? We're going to have our base, and we're going to be adding 1 to the power as we see here. So that's 2 plus 1, 3, over that new power, which would be 3. So the integral of x squared with respect to x would be x cubed over 3 plus c. Never forget your constant of integration, c. So let's look at another one. Let's say that we want to integrate a constant. Let's say that constant is a, and we're integrating it with respect to x, right? All we would have is, remember, you know, a would be equal to a times x to the 0. And we're integrating that with respect to x, right? So we're going to be having a x to the 0 plus 1 all over 1, which would give us what? A x. And we're going to be adding our constant of integration. So in other words, if we integrate any constant a, the integral will be ax plus our constant of integration. So let's say that we're integrating a function f of x, and that function is being multiplied by that same constant a, and we're integrating that. All we need to do to make it simpler is to say it's a times the integral of f of x with respect to x. So if we're integrating 9x squared, for example, with respect to x, all we would need to do is to say 9 times the integral of x squared with respect to x. And we know that the integral of x squared is x cubed over 3. So all we do is multiply that by 9, and we add our constant of integration. So this would leave us with what? If we come right up here, that would leave us with 3x cubed plus c. Now, if we were to add two functions that are being integrated. For example, the integral of f of x plus or minus g of x with respect to x would be equal to the integral of f of x with respect to x plus the integral of g of x with respect to x. And that's simple enough. So if we have, for example, the integral of 3x squared plus 4x cubed with respect to x, all we're expected to do is to integrate them as single functions. So what would that leave us with? We would be integrating x squared, and that would leave us with what? X cubed over 3. And we're going to be multiplying it by 3 plus x to the 4th over 4, which will be multiplied by 4. And then we're going to be adding our constant of integration, which will leave us with x cubed plus x to the 4th plus c. Now, one last thing I must show you requires that you remember chain rule from differentiation. So this is saying if you have ax plus b being raised to the power of n, when we were differentiating it, all we did was to differentiate the outside and then multiply by the differential of the inside. Now what we're going to do for integration is to integrate the outside and divide by the differential of the inside. What does that mean? That is telling me that the integral of ax plus b raised to the n would be ax plus b to the n plus 1 all over n plus 1, and we're going to be dividing by the differential of what is in the bracket right here, which would be a, and that would be the differential. So let's look at an example. If we have to integrate 4 over 6x plus 3 all squared with respect to x, that would tell us that we're integrating what? 16 times the integral of 6x plus 3 to the negative 2 with respect to x, right? So integrating that will give us 16 times 6x plus 3. We're going to be adding 1 to the power, so negative 1 plus 2 is negative 1. Divided by that power would be dividing by negative 1, multiplying that by the differential of what is in the bracket here would be 6. So that leaves us with what? That is telling us that the integral of this function here would be negative 16 over 6 times 6x plus 3 plus c. So here we have a list of integrals and their respective first derivatives. It is important that you know these first hand.